What's up, Algebra 2 students? Mr. Messner coming to you from my house, recovering from hip surgery. I have nothing else to do, so I figured since I have to just like stay seated and I can't move, I'm just gonna make some videos. So here you go. Here's the day 3 notes involving the quadratic equation. Okay, we're solving quadratic equations using the quadratic formula. Um, you need your calculator today, so make sure you have that ready to go. And what we've seen so far in this unit is we've been using square roots to solve quadratics. For example, we've had quadratics in like difference of squares format where we could factor, but we also could like add and then square root both sides to get x equals plus or minus 3. We've also had some equations in vertex form where we can isolate the square root before we isolate the square before we square root, getting us x minus 1 equals plus or minus 2. Then we're going to finish things off by adding 1 to both negative 2 and positive 2, giving us negative 1 and positive 3. Okay. Now let's go to standard form. This is standard form, an ax squared plus a bx plus a c. And we want to solve this using square roots too. Okay. But here's what a lot of students think we could do is like, okay, well, let's like move the 1 to the other side. But then they think, oh, I must have to square root right now. You can't do this. You're not allowed to square root over addition. You can't simplify this to be x plus root 6. You can't combine the x squareds and the 6x's. So like this is not how you're going to solve a standard form using square roots. There's another technique though, okay, where you can move some things around, use something that we knew from last unit to then help you solve these using square roots. Okay, I'm going to walk you through it. Okay, so we're going to start out by kind of doing what we think we should be doing, but I am going to decide to add 9 to both sides. Now, the reason why I do this is because when I add 9 to both sides, I get x squared plus 6x plus 9. Now, this is something that like is actually factorable. I could factor this. I couldn't factor the original one. You might want to try to factor like x squared plus 6x minus 1. And it's like two numbers that multiply to get negative 1 and add to get 6, and they don't exist. It actually doesn't mean that there's no solutions. There are solutions here. Just because you can't factor doesn't mean you don't have any solutions. So what I just did is added 9 so that I can factor this. And watch how this is going to be factored. So a times c, I'm going to just factor the left side, is 9. Two numbers that multiply to get that and add to get that b, 6. And I realized that the two numbers are 3 and 3. Now, let's remember how we used the X box to factor. And I'm just going to focus on the left side. I'm not even going to pay attention to the 10. I'm going to leave off to the side. I got x squared. I got 9. And then the middle 6x gets rewritten as 3x's and 3x's. Then I got to figure out what like gets multiplied in to give us this, or I can kind of factor out the greatest common factor. I realized that since a is 1, I didn't even have to do this. I get x plus 3 times x plus 3. Okay. Now, x plus 3 times x plus 3 is the left side. Cool. Now, a lot of times we would say, oh, the answers are negative 3 and negative 3. But that's not right because we want this left side to equal 10. But watch what I'm going to do. I'm going to say, oh, x plus 3 times x plus 3 is x plus 3 squared. And now I have something in vertex form. I've just taken x squared plus 6x plus 1, was it minus 1? Minus 1. I turn this into vertex form by what we call completing the square, like by moving this number and then adding a specific number to both sides. And that specific number, we kind of like figure it out. Actually, mathematicians figured out what that number has to be every single time so that we get this vertex form, this perfect square. And after we're ready, after this is in vertex form, we know like, oh, I can solve. The square is isolated. I get x plus 3 equals, that gets rid of that. I try to square root 10. We should always be doing this when we are dealing with square roots. We try to square root the number, it doesn't work. We try to divide 10 by any of our biggest perfect squares. 9 doesn't work, 4 doesn't work. So actually the square root of 10 is in simplified form. But we know we need both a positive and a negative number. When you're square rooting to solve an equation, you need a plus or minus. And then we finish off by subtracting 3 or adding negative 3, and we get our answers. Negative 3 plus or minus the square root of 10. Negative 3 plus root 10, negative 3 minus root 10. Those are my two solutions. I'll write those down because I feel like a lot of my students have been making mistakes with the whole adding and subtracting. They think to add and subtract that. Okay. All right. So we just solved the standard form equation using a square root, but by making it look different. We kind of had to change it into vertex form. I'm going to go through this one more example, but in the end, like what we're doing right now is not important. Okay. But this one example shows you like this process. You want to solve a standard form using square roots. You could move the 2 over to both sides. You get x squared plus 8x equals 2. Now we got to figure out what do we add to both sides. And in this case, it's not 9. It's a different number. So that I get x plus a number times x plus the same number. Well, let's think about this. This is going to be x squared. This is going to be the number times the number, like the number times itself squared. The middle is going to be the number times x and then the number times x. And when I add those two together, I'm going to get 8x. Okay? Well, like what number plus itself is 8? 4. Okay? So 4 and 4, if I use that 4 twice, I'm going to get x plus 4 squared, which is x squared plus 8x, but plus 16. Oh, okay. I want this number to be 16. This is me just showing you how I could figure it out and how it had been figured out by mathematicians what that number is going to be. Okay. And then we factor and we realize, oh, okay, this turns into x plus 4 times x plus 4. This on the right side is 18, but this is just x plus 4 squared. So I write out my factored form. X plus 4 squared equals 18. I'm ready to square root both sides. Let's do it over here. I'm ready to square root both sides. Try to simplify what I have on the right side. Square root gets rid of the square. They are arch enemies or best friends. We're not sure. Can I square root 18? No, it's not a perfect square. Is there a perfect square that goes into it? Yes. Start with the number 18 and divide that by 9. We've practiced this. That means 9 times 2 is 18. That means root 9 times root 2 is root 18. Root 9 times root 2 is root 18. I need a plus or minus because I square rooted to solve an equation. I get 3 root 2. And then I finish off by subtracting 4 from both sides, giving us negative 4 plus or minus 3 root 2. That gives me two solutions. A -4 plus 3 root 2. Now, that's an ugly number. I could type that into my calculator, but it's going to be an ugly decimal. But it is our solution. -4 minus 3 root 2. I'm going to show you the fact that it is our solution to this equation. X squared plus 8x minus 2. Desmos always freaks out when I go do it. Oh, we're good. So y equals, I'm going to graph x squared plus 8x minus 2. I see I have 0.243 and negative 8.243. Well, watch. These are my x-intercepts. These are my solutions. -4 plus root 3, 3 root 2. Is that 0.242. And if I looked in the other direction, I'd get -8.243. So like, great. Now, what you probably realize is like, man, this is a little bit complex. You got to like figure out a number and you got to like know how to factor. And if you know how to factor, then you figure out this number. And it's a complex process. This is called completing the square. Okay. Well, mathematicians realize something, that you end up doing the same thing every time. If you have some ax squared plus bx plus c, you could solve any ax squared plus bx plus c equals 0 by doing the same process. Okay? And here's me showing you what the mathematicians did. You don't have to understand this. You don't have to follow this. I'm just going to kind of walk you through that. They realized, okay, first, like, let's just have x squared. They divided everything by a. And that just turned into b over ax and c over a. Okay? And then they're like, okay, let's pretend this is like x squared plus 8x plus minus 1. They're like, let's get rid of that 1. Well, they're like, okay, let's get rid of the c over a. They subtracted c over a. And then they just got x squared plus b over ax equals negative c over a. Then they figured out, kind of reverse factoring, what is the number that we need to add to both sides? That goes right here and right there. What's the number that always needs to go right there? So that I can factor this left side. And when I factor this left side, it's a perfect square. And they realize that number is b divided by 2a squared. Let's think about it like that. 8 divided by 2. 8 divided by 2 is 4. Times a was 1. Squared is 16. So it's like you took the number, you split it in half, and then square it, as long as a is 1. And they're like, all right, I'm going to add that to both sides. They then simplified the right side a bit. They decided to square the top and square the bottom over here. This is how this turns into b squared over 4a squared. But they kept this like this on this side. They then realized, all right, I could combine this right side if it had a common denominator. Again, you don't have to follow this. This is what mathematicians kind of figured out through the process of completing the square. And they realized you get this b squared minus 4 times a times c all over 4a squared. Okay? And then on the left side, we get this thing that can be factored. It can be factored to be x plus b over 2a times x plus b over 2a using kind of the process we were doing in the other two examples at the beginning. So they factor the left side, and it turns into that. Okay? And now that's like, oh, this is vertex form. We could square root both sides. When we square root the left side, the square goes away. We're just left with this. When we square root the right side, they're going to square root the top. And they're square rooting the bottom. And they realize that the bottom square rooted is just the square root of 4 and the square root of a squared. Well, the square root of 4 is 2. The square root of a squared is just a. And since they're square rooting, they have a plus or minus. And then they finish things off by subtracting b over 2a. And here's b over 2a subtracted. They realize, hey guys, don't worry about doing this whole completing the square. We completed the square for you. This is what you can use for any standard form of a quadratic equation, preferably when things are not factorable. You have this formula. As long as you know what A, B, and C are, you could plug those numbers. You could plug the number A, the number B, and the number C into this formula, and boom, you'll have your answers. Okay, I'm going to show you. We're going to do the first two examples just using the formula. Okay, now this might not be what you're used to seeing with the quadratic formula. A lot of times they decide to combine these two things because it has a common denominator to be like x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I actually prefer this method, and I think it's easier to simplify, and I think it's easier to understand because we have seen this before. I don't know if you remember seeing that before, but this was the location of our axis of symmetry. It's the x-coordinate of our vertex if you're given an ax squared plus bx plus c. So really what this formula is like the middle plus or minus a distance to get to your x-intercepts. Do you have to worry about that? No. Okay, here's what you need to worry about, guys. If we give you a standard form, an ax squared plus a bx plus a c, and you can't factor this easily, but you still want to get the solutions, all you need to do is identify the number a that comes before x squared, the number b that comes before x, and the number c. Okay? Take that, plug it into your formula, and you will get your solutions. Now, watch this. We've already solved this in just like that special way on the first page. We got -3 plus or minus root 10. Okay, -3 plus or minus root 10. Let's get those same solutions, -3 plus or minus root 10, a different way. All right, have your calculator ready. Let's start with the opposite of b over 2a. And I'm going to use this side, and I'll switch over to that side in the future. So in my calculator, I'm going to do this like all at once because I feel like when students sometimes write things out, they make mistakes. I'm going to use my fraction button, and I'm going to say the opposite of b over 2 times a. And I get -3. What I did was the opposite of b over 2 times a, and I got -3. Okay, I did this all at once. Now I got a plus or minus. Now, we got the 2 times 1 on the bottom, so let's leave that 2 times 1. On the top, I like to do everything inside the square root first and then worry about the square root later. So let's worry about just the b squared minus the 4ac. Okay, I'm going to do this all at once, but I'm going to show you what I'm going to type into my calculator. 6 squared minus 4 times 1 times -1. Okay, in our calculator, using parentheses, 6 squared minus 4 times 1 times -1. Please use parentheses when you're squaring numbers. And I get 40. That means I have the square root of 40. Notice I did not use the square root yet. So I end up with 3 plus or minus the square root of 40 over 2. Well, I don't like the square root of 40. It's not simplified. The square root of 40 is not an easy number to figure out. But what is a perfect square that goes into 40? Well, it's not 16. It's not 16. It's not 9. It's 4. So 4 times 10 is 40. So root 4 root 10 is root 40. And the square root of 4 is 2. And what I can do, because I'm dividing and multiplying and there's no addition, I can say 2 divided by 2 is just 1. Or 2 root 10 divided by 2 is just root 10. And look at the answers that I got. -3 plus root 10 and -3 minus root 10. Just like I got before, but not with this crazy mathematical, figuring things out, completing the square process. Okay. Lots of calculator, lots of just work. You have to do it. You have to practice. If you just think you can sit there and just figure it out one time, you've done it once and you're done. No, you have to practice. Okay. All right. The next ones are going to be -4 plus or minus 3 root 2. I know that's going to be my answers to the next one. Oh, actually, it's a different equation. X squared plus 8x plus 12. That's not this one. I have x squared plus 8x minus 2. So anyways, I could do the same thing here if I wanted to. A would be 1, B is B, and C is 2. So 8 divided by 2 times 1 is 4. I should just go into the rest of the notes. Opposite of B over 2 times 1, plus or minus the square root, B squared minus 4AC. -72 over 2 times 1. -8 divided by 2 is -4. 72 can be divided by 9. Ooh, it can be divided by 16. No, it can be divided by 36. So this is root 36, root 2 over 2. Root 36 is 6. 6 divided by 2 is 3. Boom. I got those same solutions. Okay. Sorry for the tangent, but let's go back into, okay, new equation. Don't do crazy algebra. It's in standard form. We could try to factor. I'll show you factoring later. But let's say we hated factoring. We hated last unit. Let's just use the quadratic formula. Either this guy or this guy. It's up to you which one you use. A is 1, B is 8, C is 12. Don't change any of the numbers yet. Those are the numbers. Everything is just shown to you there. You're going to use these numbers. Okay. We start off with -b over 2 times A. I got plus or minus square root of b squared minus 4 times A times C all over 2 times A. That's it. That's my answer. We're correct. Now we just got to be able to simplify it. So on the left side, it's really -8 divided by 2, which is -4. If you need to figure that out, great. If A is something different, though, use the fraction button so you don't make mistakes. -8 divided by 2 times 1. We're using parentheses everywhere. I get -4. Work inside the square root first. So let's do 8. 8 squared minus 4 times 1 times 12. It's 16 over 2. So square root 16 over 2. Let's check. Oh, I know what the square root of 16 is. It's 4. So this is -4 plus or minus 4 over 2. 4 over 2 is just 2. My solutions are x equals -4 plus 2, -4 minus 2. -4 plus 2, you can use your calculator, is -2. Negative 4 minus 2, you can use your calculator, is negative 6. Now, I didn't need to use the quadratic formula for this one. If you remember from last unit, unit 5, two numbers that multiply to get 12 and add to get 8 are 6 and 2. Since it's a is 1, that's the factored form. Boom, negative 6, negative 2. Okay? Opposite. Okay, but just showing you how the quadratic formula works. What the quadratic formula helps you with is if you can't factor. If you can't factor, it doesn't mean that there's no solutions. Australia is already beating France. Oh my gosh. What is going on in the World Cup? Australians just getting after it, huh? I wish the United States of America would get after it more and like attack more instead of just like trying to be fancy and pass the ball around when we're not as good as everybody else. All right, anyways, A is 1, B is 4, C is negative 6. We got opposite of B over 2 times A. We got square root of B squared minus 4 times A times C, all over 2 times A. I got negative 4 over 2. I get, let's work on this square root. If I don't have parentheses, if I have parentheses around that, it's no big deal. If I don't, it's no big deal. What just happened? 4 squared minus 4 times 1 times negative 6. 40 over 2. You have to simplify root 40. Square root of 40 is not a nice number. It's the first thing I check. Okay, second thing I check is there any perfect squares that go into that? 16 doesn't work, 9 doesn't work, 4 works. We did this earlier. 4 times 10 is 40. So I get negative 4 over 2 plus or minus root 4 root 10 over 2. Root 4 is 2. I could simplify the left side first if I wanted to. 2 divided by 2 is just 1. Negative 4 over 2 is negative 2. I get x equals negative 2 plus or minus root 10. So that's negative 2 plus root 10. That's negative 2 minus root 10. Okay? If you graphed it, you'd be able to see those are the exact decimal locations. And that's what we got to go with. Careful when B is negative. Careful when A is not 1. A is 2 here. B is negative 8. And C is 7. Watch. Opposite of B over 2A. That's a negative 8 over 2 times A. That's a negative 8 being squared in parentheses, minus 4 times 2 times 7 over 2A. Just use the formula, guys. It's not that bad, but you got to do it. Now, a negative 8 is positive 8. Okay? So this is positive 8 over 4. If you make a mistake and do this, 8 divided by 2 times 2, you're going to get the wrong answer. This is why I tell you to use the fraction button. Eight over 2 times 2. Boom, 2. Because this is 8 over 4. Okay? This is some square root over 4. Let's figure out what's in the square root. Got to figure out how to use parentheses. Can't. I don't know the shortcuts. All right. So anyways, negative 8 in parentheses minus 4 times 2 times 7 is root 8. Great. Simplify that square root, though. 8 cannot be square rooted. Square root of 8 is bad. But you can divide it by a perfect square, like 4. So this is 4 times 2, which is 2 root 2. Now, 2 divided by 4 is the same as 1 divided by 2. If you want to, your calculator is not going to like you trying to do 2 root 2 over 4. I don't know. Maybe it does. No. So you really just try 2 over 4. Oops. And you get 1 over 2. Like 2 divided by 4, divide the top and bottom by 2. We did this back in, unit 1. We get that. The 2 turns into a 1. The 4 turns into a 2. So I get 2 plus root 2 over 2. I get 2 minus root 2 over 2. Man, if Australia beats France and Saudi Arabia beats Argentina, this will go down in history as a crazy day. Okay. Identify A, it's a number. Identify B, it's a number. Identify C, it's a number. C is negative. Be careful. Formula. Opposite of B. It's like negative B is negative 7. Over 2 times A. If you want to just write that as 2 times 2, which is 4, like do it. Do that. Whatever can make things a little bit easier on you. Plus or minus. Square root. B squared. Minus 4 times A times C. All over 2 times 2. This is positive 7/4. Let's figure out what's in here. A lot of stuff and numbers to keep track of. Oh, that's nice. 81. Okay, try to simplify that. This is where we always like to check the first number because, it's just 9. So I get 7/4 plus or minus 9 over 4. So we get 7/4 plus 9/4, and we get 7/4 minus 9/4. Since this doesn't have a square root, we can figure that out. Use your calculator. It's fine. 7/4 plus 9/4, though, it's a common denominator, is going to be 16/4, which is 4. And then 7/4 minus 9/4 is negative 2/4, which is negative a half. So that's how I get those two answers. Turns out you could factor this. But again, a lot of you struggle with factoring. The day 2 of factoring was tough for a lot of students. All right. Four more. Make sure everything's on one side. I'm just going to kind of blow through these. And I'm going to do the work on my calculator instead of showing it on the other calculator because it takes too long. I use my phone. Remember when we factored, you got to make sure everything's on one side and you identify the correct A and B and C. A is positive 3, but B is negative 5 and C is 1. A is always what's next to x squared. B is always what's next to x. Okay? I got the opposite of B over 2 times A. I got plus or minus. Ready? B squared is 25. So 4 times 3 times 1 is 12. 25 minus 12 is 13. I get the square root of 13 is the b squared minus 4ac. 25 minus 12. Yep. All over 2 times a. And I can't simplify the square root of 13 because there's no perfect squares that go into it. And France just scored. Is that Griezmann? All right, well, it's maybe not that exciting of an upset day. France is back to being normal. So this is it. You can try to divide 13 by 4. By 9, it doesn't work. So all you get is this. 5, 6 plus root 13 over 6. 5, 6 minus root 13 over 6. And guess what, guys? Like, you could have it like this. You could have it like that. But I prefer it like this because it just shows you, like, hey, here's your middle, here's your vertex. Add this distance, you get to one x-intercept. Subtract this distance, you get to the other. All right, here's the same thing. Like, make sure everything's on one side before going crazy. A is 4, B is positive 4, C is negative 1. I'm going to go through this quickly. Opposite of B over 2 times A. B squared is 16. 4 times A times C. Ooh, is that going to be 32? 4 times A times C is negative 1, is negative 16. So I have 16 minus negative 16. So that is going to be 32. Just use your calculator, guys, to get that 32. 4 goes into 32. 16 goes into 32. That's nice. So this is root 16, root 2. Again, use your calculator to divide 32 by all the biggest perfect squares, and you get 4 root 2 over 8. 4 over 8 simplifies to be 1 over 2. You can use your calculator to help you with that. But this is my answers. I got negative 1 half plus root 2 over 2. I have negative 1 half minus root 2 over 2. Okay. We want you to get these simplified radical answers. We don't want you to just go to decimals. If you were to go to decimals, like, it's a little bit easier than you simplifying these radicals, getting answers. Simplifying radicals is very important, especially when we go into the next lesson. What happens here? I don't know. $36. 4 times 9 times 2 is 72. I don't think I wanted to do that. We got a negative. Try to plug this into your calculator. Doesn't work. There are no real solutions. Okay? No real solutions. However, next lesson you're going to learn there are actually imaginary solutions. But since you can't take the square root of a negative, that's bad. The other situation, I was supposed to do this. Make this a negative 2x. Okay, watch this. If A is 1, B is negative 2, and C is 1, what happens here? Okay, so I get x equals the opposite of B over 2 times A. And I get plus or minus square root. B squared, negative 2 squared is 4. 4 times 1 times 1 is 4, all over 2A. Here, I get 0, which means x equals 1 plus or minus 0. Well, if I'm adding and subtracting 0, that means your only answer is 1. I wanted you to show those two situations. If what's underneath your square root is negative, no real solutions. If underneath your square root is 0, you're only going to have one solution. This is the situation where your solution is the vertex and they're located at the same location. Okay, we're used to having two solutions. Sometimes we can have one. If you graphed x squared minus 2x plus 1, you see the vertex is on that. Okay. All right. That's it. Use your calculator, practice. Mistakes are made with calculators. Shouldn't be made with the formula. It is a formula, so we use the formula. And France just scored. Is that Olivier Giroud? I love Giroud. All right, well, go USA out there. Later.